Good morning. In the last lesson, we talked about what complex numbers are. So they take that form a plus bi, where a is a real number and bi is an imaginary number. And then we went through adding and subtracting, which really are just combining like terms. Combine real numbers with real numbers and imaginary numbers with imaginary numbers. Now we know from dealing with variables and such that we can't add, say, 2 plus x, because they are what are called unlike terms. But we can multiply 2 and x and we get 2x. And the same is true with our complex numbers. So while you can't add a real number with an imaginary number, you can multiply a real number with an imaginary number. So we are going to look at a couple of examples and like just the things that we need to be paying attention to when we're multiplying. So there we go. Multiplying. The key thing we want to make sure we're paying attention to is this. We want to make sure we take care of the I squared. Because when you take a complex number and you or an imaginary number and you multiply it by another imaginary number, you're going to have I times I. So if you see I times I, remember that that's I squared. And I squared, we know from a previous lesson, is -1. I'm going to repeat this because it's a common misconception. I does not equal -1. I squared is equal to -1. So when you start multiplying your complex numbers, there's a decent chance you're going to end up with an I squared somewhere in there, and then you will substitute out the I squared with a -1. So I've got 2 examples to show you, and then we'll look at 2 practice, and then we're going to talk about a common mistake. I've alluded to it in the previous lesson. That's a silly mistake, and we want to avoid it because it's totally unnecessary to make this mistake. So let's look at example 1. This is going to be 2i, which is just an imaginary number, times 3 plus 5i. Now remember that math is consistent. Like what we learn in one unit is not independent from what we learn in a different unit. The rules of math don't change. They just don't change. So once you know the rules, you can actually do a lot of math even if you've never been taught that math. It's why it's so important to know the rules and not just a bunch of steps. So if you were to see this problem as a problem with x's instead of a problem with i's, you would distribute the 2i over the parentheses. You kind of look at that and you see like, okay, I just distribute it. That's exactly what you're going to do. You're going to distribute it. So if you had 2x times 3, I hope you would tell me that that was 6x. Well, 2i times 3 is equal to 6i. Plus 2i times 5i, well, 2 times 5 is 10. And then I times I is going to give you I squared. I don't know why students want to drop that off. Like I times I is I squared. So just where you would come up with like an x times x is x squared, I times I is I squared. Now the caution I gave you was to make sure you take care of the I squared. I squared is equal to -1. So where you see the I squared, that number or that I squared can be replaced with a -1 because we don't want i's floating in the problem where we don't need them. And what that does is it creates a couple more steps. 10 times -1 is -10. Now, if you remember, the form for complex numbers is a plus bi. So we will generally, unless we are specifically told otherwise, we will put the real number in the front and the imaginary number on the back. So instead of saying 6i plus -10, I'm going to say -10 plus 6i. And that last step is a little bit of a formality to make sure that your answer is in the form that it would be accepted in. Really, the only thing that makes this any different from multiplying with like x's is that when you have the I squared can be substituted with a -1. Let's look at the next example. next example is going to be two complex numbers. So 4 plus 3i times 2 minus 5i. So if I gave you this problem with variables and I said multiply it, you would FOIL, your distribute, okay? That's what you would do because that's what you've done before. And math is consistent. So just because we're dealing with a complex number here does not mean that we don't FOIL it. That's exactly what we're going to do. So we're going to do 4 times 2, which is 8. 4 times negative 5i, well, 4 times negative 5 is negative 20, and it would be negative 20i. Then we'll distribute the 3i. 3i times 2, well, 3 times 2 is 6, so that is 6i. And then 3i times negative 5i. Well, 3 times negative 5 is negative 15, and then I times I is I squared. Please remember that that is an I squared. Anytime you are multiplying I times I, you are going to get I squared. It's a common mistake, and it's a bit of a strange common mistake that I don't quite understand why so many students do it, but I know a lot of students do. So make sure that you're paying attention to that. Now, just like with other types of FOILing problems, the middle terms here most of the time can be combined. And so I'm going to have 8, and then we'll have negative 20 plus 6, which is negative 14i. Now, remember our caution. When you're multiplying, take care of the I squared. You can't leave it as an I squared. It's what makes these different from, say, doing a problem with an X. I squared is equal to negative 1. Now we realize we actually have a little bit more work that we can do because now I have two terms that are real numbers. Negative 15 times negative 1 is positive 15. And I'll kind of repeat that because we do have quite a few negatives in there. Negative 15 times negative 1 is a positive 15. And now I can do 8 plus 15 to get 23. And you'll notice I did make a mistake right here. And this is like a careless thing. I dropped the I in it when I rewrote it. So it was negative 14i. And I copied it as negative 14. So I caught my mistake. I'm going to make sure I put that back in there. And then 8 plus 15 is 23 minus 14i. And so it's got a few more steps than a FOIL problem with a variable, but the principles are all the same, and this is a review from a previous class. So you guys need a chance to practice. That's the only way you're going to figure out how to do it and figure out what mistakes you're likely to make. So the first practice problem is 6 plus 4i times 2 plus 2i, and the second problem is 4i, no, there we go. Didn't want to write on that part of my iPad. 4i times 3 plus 2i. So I'm going to pause the video and give you guys some time to work that out. And then what we'll do is we'll go over it in class, and I'm going to go over it in the video for folks that are watching at home, but in class we'll fast forward through this next part of the video. Okay, so for this first problem, it's a FOIL problem. So we're going to do 6 times 2 is 12. 6 times 2i is 12i. 4i times 2 is 8i. And 4i times 2i is 8i squared. Remember that I times I is I squared. The two middle terms combined, so I get 20i. 12 plus 8 is 20. And then over here, the I squared is equal to negative 1. So now I have 8 times negative 1 right here. 8 times negative 1 is negative 8. And now I have something else that I can combine here. I have 12 minus 8. Well, 12 minus 8 is 4. And so your final answer for that one should be 4 plus 20i. Not a hugely long problem. It is 1, 2, 3, 4 steps at the most to do that. And a lot of students, as you do a lot of these problems, like my dual enrollment college algebra students who have had this before, some of them have done it in pre-calculus also, But they will go straight from the 8i squared to the negative 8. Like they kind of go through this process of substituting and flipping the sign in their heads, mostly because they've done it so many times that they don't need to think about it that hard. And as you practice, you'll get to that spot as well. Second one, we're going to distribute. So 4i times 3 is 12i. And then 4i times 2i, well, 4 times 2 is 8. And please don't forget, I times I gives you I squared. But I squared is equal to negative 1. So this becomes 12i minus 8, which is technically the right answer, but it's in the wrong form. So we do want to write it so that the real number is out front and the imaginary number is the second one. So instead of 12i minus 8, I'm going to do negative 8 plus 12i. Make sure that you move the operator with it. Okay, this is actually a plus negative 8, and so the negative would move with it. Okay, next thing is a huge caution. So here's the huge caution. Pay attention to the operator in the problem. Just because you see parentheses doesn't mean it is multiplication, because you're going to see those parentheses in the addition and the subtraction problems as well in order to separate the complex numbers from each other. So please, 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 you'll notice from the last couple of lessons that adding complex numbers is maybe 1 step, subtracting is maybe 2 steps, multiplying is usually around 4 steps. So if you have an adding problem and you misread it as a multiplication problem, you will spend all kinds of extra time doing something, and not only are you taking extra time to do it, but it's wrong. It means I can't even give you credit for it because you did the wrong thing. So please, please, please pay attention to the operators. So on this slide, you don't have to write them down. I don't want anybody copying this. The question is just, which operation do you see? Identify the operation that's happening, because if you look at it and you see all these parentheses and you're like, oh, look, a bunch of multiplication problems, you are going to run out of time on your quiz, and it's going to be because you decided to do extra long, harder work that's wrong. Please don't do that to me. Please don't do that to me as your teacher where I have to take off points because you are not looking at whether it's a plus sign or a times sign. So take a moment. We'll pause the video. You don't even have to write it down. I just want you in your head to look at each of these problems and indicate what the operation is. Okay, so hopefully you answered like so. This is a subtraction problem. I hope you recognize that is subtraction. The second one actually is multiplication. When you don't see an operator, you assume that it's multiplication. Third one is another subtraction problem because you have a times sign. And the fourth one is an addition problem. And every year I go over this, every year I emphasize this, and every year someone on the quiz is going to multiply all of them together. They're going to take all kinds of extra time to do extra work that has extra steps, and then they're going to get the problems wrong. So please, please, please make sure you are paying attention to what the operator is. Last thing that I want to look at is another multiplication problem, but we spent quite a bit of time talking about these things called conjugates. So I want you to notice something. What happens if we multiply conjugates? So I might give you guys some time to work on this on your own. We'll just make a pair of conjugates, 2 plus 4i, and then the conjugate of that would be 2 minus 4i. So I might pause the video here and give you some time to work it out, or we might do it together. Depends on where the clock is at this point in the class. Okay, so if you're doing this on your own, we would FOIL this. So we're going to, because remember, like, conjugates come from the difference of squares. And so we know with conjugates, the middle part always drops out. And so we're expecting like the middle part to drop out, but then something interesting happens with the parts that are left. So we have 2 times 2 is 4. 2 times negative 4i is negative 8i. 4i times 2 is positive 8i. And these are the twos that cancel out. And that always happens when we multiply conjugates. Now, 4i times negative 4i, well, 4 times negative 4 is negative 16. And don't forget, I times I is I squared. Just like x times x is x squared. I times I is I squared. The middle parts cancel out. Negative 8i plus 8i cancel each other out. They add up to 0. And we're left with 4 minus 16. But remember that I squared is equal to negative 1. And what you notice happens right in that line there is that all of the i's are gone. These two i's canceled themselves out, and that I was an I squared, which actually is a negative 1. And so let's finish this out. Negative 16 times negative 1 is positive 16, and the problem becomes 4 plus 16, which is 20. And the key thing to note there is that it's a real number. So you might be asking, well, does that happen every time you pick conjugates and you multiply conjugates together? Or was this just the exception? So you might want to just convince yourself, like pick another pair of conjugates and multiply them together and see what happens. But what you will see is that when you multiply conjugates together, you actually get a real number because the middle i's cancel each other out and the i's down at the end are actually an I squared, which is negative 1, which is a real number. That's going to become important in our next lesson, which is dividing complex numbers.